Hey, how's it going? Now, Honkai Star Rail has a big emphasis on critical hits. Every guide is talking about critical hits, increasing your rate and your damage, but how important are they really? In the scope of things, it's another multiplier. It's another thing that you can multiply by to increase your damage, so that's always great to have. And critical hits are the most unconditional way to scale a unit's on-hit damage. It's better than attack percent, it's better than damage percent, it's better than speed, and for most times it's better than defense reduction. Defense reduction requires other stackable defense reductions in order to become better. Uh, but generally, critical hits is the main way that a unit gets more damage output. This is essential in hyper carry comps, dual DPS comps. It is not in damage over time comps, but generally, this is the main strategy that you use to do more as an extra multiplier. So, one of the questions is how is this multiplier actually come into effect? And critical hits actually don't happen all the time, which is why there is an expectation value, or what you would generally expect coming from your crit damage and your crit rate. So if we consider that you have a standard attack, in this case we're doing 1 damage, you have two paths that can go down. You can either get a critical hit, you can hit the crit, or you can miss the crit. If you hit the crit, how much damage you do is 1, which is your standard attack, and it actually scales up based on your crit damage. If you miss the crit, you don't get any bonus from the crit damage. You just stick with your standard attack. Now, one question though is, how likely are you to hit the crit or miss the crit? That's actually scaled by your critical hit rate. The critical hit rate determines how likely you are to get into the critical hit damage, and the likelihood that you miss the crit is actually 1 minus your critical hit rate. So the way that you do expectation values in this is you add the results and you scale it by the likelihood of occurrence. So from the critical hit rate side, you can multiply the likelihood it happens, which is the critical hit rate, and then the value is 1 plus the crit damage. On the miss side, you multiply 1 minus the crit rate, which is the likelihood, times the actual value, which is 1. If you add those together, you actually find that your expected amount of damage that you do is 1 plus the crit rate times the crit damage. Or in simpler terms, I'm going to call this the crit multiplier, or CM. It's 1 plus CR plus CD, where crit rate is CR and crit damage is CD. So if you want to maximize this CM multiplier, you just want your crit rate and your crit damage to be as large as possible. Obviously, crit rate can't go above 100%, but if we can make those as big as possible, we get a big multiplier, more damage. Uh, the problem though is, relic limitations, kit limitations, my team limits. These are all things that prevent me. Like, I can't just have 100% crit rate and 1,000% crit damage. So there are limits or constraints, and that requires us to optimize how much crit rate do we put in, how much crit damage we put in with this constraint. So, the first example, we have a limited crit rate and crit damage. If I were to give someone 100 percentage points, you can allocate it into either crit rate or crit damage. How would you assign them? Well, I'm not going to put them all into crit rate, because if I do that, then I have no percentage points into crit damage. And when I do the multiplication, crit rate times crit damage, it's just 0. So I don't benefit much by hitting every crit, but every time it crits, it doesn't do anything extra. And it doesn't make sense to put it all into crit damage, because then my crit rate is 0. So even though my crit damage is huge, it never happens. So that doesn't help either. Probably going to be some mix up in between, but we're going to look at a precise way to look at it. Because it's a multiplication of, we want to maximize crit rate times crit damage, the best way to think about it is it's like a rectangle with dimensions of crit rate and crit damage. I want to make this rectangle as big as I possibly can. And I have a couple options. I can either increase crit rate or crit damage. If I want to increase crit rate by 1, I get an extra sliver. I get some extra area. And the dimensions of this extra area by doing crit rate is, well, this is a rectangle of 1 by CD. So that's how much area I would get if I increase the crit rate by 1. Okay, if I want to increase the crit damage by 1, I get some more area. I get a rectangle of 1 by CR. And this area is CR. So if I were to look at comparing both of them, I want to consider the change in areas if I were to add 1 point. So what I'm really doing is which one will make my rectangle bigger? Which area change gives me more? And in this case, the red rectangle gives me a bigger area change because the crit damage is bigger. So I would request that, hey, by doing 1 more to the crit rate, I would get a better area change, so I should increase the crit rate. So in the inequality, it is, in this case, the crit rate is less than the crit damage because the red rectangle is bigger. I should add to the crit rate side. If the opposite were true, and the crit damage was bigger, you could imagine a very short but very wide rectangle. It would be better to add to the crit damage side, and then that would get a bigger rectangle. So these two comparisons is what helps me to identify that, hey, I guess the breakpoint is if the crit rate and the crit damage were the same, it would be actually a square, and increasing to either side of the square gets me the same area. So that's kind of the equilibrium point, or the point where neither gets you any more. So you can imagine that even in this situation here, it is becoming more square-like as I add to the crit rate. If I start incorrectly adding to the crit damage, it becomes less square-like. So that is the solution that we actually find. The best distribution of stats would be to put half of it into crit rate and half it into crit damage. Crit rate of 50% and crit damage of 50%. So this solves the solution. If I have 100 points and I can allocate them freely. But this considers that it's an even trade-off between crit rate and crit damage because I can put 1 into each. In the game, crit damage is actually twice as abundant than crit rate. For every 1 crit rate I add, I could have gotten 2 crit damage. This is namely seen in the main stats and the substats. They're a twofold multiplier, crit damage to crit rate. So actually I have to modify it. For every 1 crit rate over here, I'm actually giving up 2 amounts of crit damage. So that's why in this situation here, if I want to add 1 to the crit rate, I have to compare it against adding 2 points to the crit damage. So it's not an equal trade-off anymore. But the argument is still the same. I still want to compare the area change. If I want to add, do I want to add 1 to the crit rate, or do I want to add 2 to the crit damage? Well, I'm still doing my area comparisons, and the area change from adding a crit rate is 1 by CD, and the area change from adding 2 to the crit damage is 2 times CR. So in this case, it's a little closer. It's a little harder to determine immediately which one's bigger. But In general, if the crit rate is twice as much as um, if two crit rates is greater than the crit damage, I should add to crit damage. And if the crit damage is more than twice as much as the crit rate, I should add to the crit rate. Your breakpoint is when your crit rate is half of your crit damage, or 2 CRs is equal to CD. This is where the 2-to-1 ratio, where I want twice as much crit damage as crit rate, is actually derived from. So this is where you want to compare your stats. You want to make sure that this is the best distribution, it's an equal distribution. You don't have too much crit rate because you're actually giving up on crit damage, and you don't have too much crit damage that you're actually giving up on crit rate. So the 2-to-1 comparison, crit damage to crit rate, is a very easy method to compare. So if we take an example, let's just throw the 2 to ratio on everything. Here are the unit stats. Do you want a crit damage roll of 6.48 or a crit rate roll of 3.24? These are both high rolls of substats, and you can see that the crit damage roll gives you twice as much of a numerical value than the crit rate roll. So let's see what the unit stats are. They have a crit rate of 45 and a crit damage of 95. If I look at it and I double the crit rate, I'm comparing 90% with 95%. So in this case, since 95 is bigger than 90, it would be better to put it into the crit rate, which is the correct solution. But if I add an extra condition, like this is a Yan Qing's passive, which actually gives me 21% crit rate and 33% crit damage, their true stats in the combat actually look like a 66% crit rate and 128% crit damage. If I use the 2-to-1, I'm looking at 66 times 2, which is 132, which is actually bigger than 128. So since 2 times the crit rate is bigger than the crit damage, I should actually add to the crit damage. So you actually have to consider some of these other outside factors before you just throw the 2-to-1 ratio on everything. So commonly, you'll find other sources of crit in some examples below. Passives or eidolons. So Imbibitor Lunae can get 4 stacks of crit damage, so that's something that would be needed to consider. Argenti's Talent can stack 25% crit rate. Jing Yuan's Trace can add 10% crit rate and 25% crit damage. Herta's E2 Eidolon can stack 15% crit rate. Fu Xuan's Skill, which is a completely different unit entirely, also gives 12% crit rate. So it's important to consider that even things like your team, your eidolons, your traces, don't immediately show on the unit stats, but they do need to be considered. Similarly, conditional relics, for example, the imaginary set gives 10% crit rate to debuffed enemies and 20% crit damage to imprisoned ones. And the broken keel gives all allies 10% crit damage. In order to maximize your distribution of crit rate and crit damage, you do have to consider these external sources too, and get that as close to the 2-to-1 ratio as possible. So this 2-to-1 ratio idea is very universal, and the fundamentals of it is really keen to understand. I'm going to give one final follow-up problem, and this is kind of the culmination of knowing the fundamentals of how this crit rate, crit damage is derived. If I consider, a sub DPS Xue Yi, it has a crit rate of 55 and a crit damage of 90%. Okay, cool. It looks like the crit rate is a little bigger than we expect, but I'm not going to do exactly the substats. I'm considering between two inner piece sets. I'm going to assume that only the crit stats matter and some of the side effects don't, and they have the same substats. But if I were to pick between inert Salsodo that gives an 8% crit rate, or a broken keel that gives a 10% crit damage, which one should I pick? Once again, assuming that the crit stats are the only one that matter and has the same substats. I know there are external side bonuses that each of them give, but I'm going to call them equally good. This final follow-up question asks, which set should I pick? And you need to show why the broken keel is actually the wrong answer to pick. And for completeness, what set of crit rate and crit damage values actually give the wrong answer than using the 2-to-1 method? This is a final culmination of understanding crit rate and crit damage because knowing the fundamentals of it can show why one decision is better than the other and why crit rate and crit damage have been derived from. So hopefully everyone can attempt this on their own, and make sure to like, comment, and subscribe for the solution, and keep watching for more Honkai Star Rail stats and theory guides.